All right, it's 10 a.m. So we're gonna start with today's webinar. Another warm welcome to everyone who just joined in the last minute. Let's get right into it. So so today's webinar is about individual room control and efficient heating with KNX. So my name is Bastian Elsner. I'm the CEO of Elsner Elektronik, and our company produces devices for building automation, building technology, and we are very well known for our sensor technology. We're also going to present some of the products over the course of today's webinar. But let's start with the heating control first. One general question. How many of you guys have turned down the heat control when you left the house this morning? You can give me a quick heads up in the chat, that would be nice, but it's not necessary because I believe probably most of us did not. Another question. What do you think is the comfort temperature? Or is the comfort temperature subjective? I think everyone knows the situation depicted in the photo. The heat sensation of people is very different. In the same temperature, someone can feel comfort, and another person in the same temperature can feel that it's not really comfortable. So people's sensation of warm varies greatly. Nevertheless, some people think comfort can only be achieved with higher room temperature, but in fact, comfort can be achieved with even comparatively low room temperature. You can do several things to avoid the sensation of cold inside. So you can avoid drafts and you can avoid big temperature jumps. Also, because those are perceived as very unpleasant by most people. In order to achieve a good comfort temperature for everyone, we're gonna talk about the individual room control today. And we're doing that on the example of the KNX system. So we have a couple of learning goals for today. After this presentation, you will be able to determine the optimal temperature in different rooms. You know how to apply the principle of individual room control with KNX. You can also distinguish and correctly apply the different modes of operation of the control types. Next up, you will be able to select the appropriate room controller for your specific building automation project. Next up, the agenda. First, we'll have a look at the optimal room temperatures because they are different than you might expect it. Secondly, we will learn about the principle of individual room control. After that, we're going to discuss different control types, for example, the 2-point and the continuous controller, but also the PI control. Next up, we will learn about the operating mode, switching in the room temperature controller, and afterwards we will talk a bit more about the two-stage heating. In the last part of the webinar, we will show some of our devices that we manufacture here in Germany that you will need to use in order to achieve individual room control, all the components that you will need for it. One more information because before we dive into the different room temperatures, this webinar is live today. So it would be great if we could make it as interactive as possible. So if you have any questions over the course of the webinar, feel free to use the question functionality. You can post questions on the top right corner. So there's a square with a question mark inside. Simply click on it and write your question inside. We won't be answering all the questions the minute you will ask them. We will choose the right timings and probably we can also go back to the slides that are concerning the question. Another information is that we will share the recording of today's webinar plus the presentation itself as a PDF to all participants from today. Also, we will be sharing some feedback forms. So this is the second year of the Elsner Academy, and this is actually the first webinar that we're holding in 2024. So it would be great to hear how you guys liked the webinar, if you wished for some more deeper technical insights, or if it was good as it is. So your feedback is highly valued, and we want to get better with our webinars, so please share if you didn't like something that much. All right, that much about the webinar organization, and I'd say let's get right into it. So, before we look at the control of the room temperature, we need to look at the different temperature ranges in the building. So, here I prepared a little graphic for you, and this might seem surprising. So we're saying that in the hallways you don't need that much of a temperature, so it doesn't need to be that high. In fact, between 16 and 18 degrees, because you usually don't spend that much time there. Also in the bedroom, for example, it's proven that you sleep better if it's not too warm. It's good for your health. In the kitchen, on the other hand, and in the living room and in the office, where you spend quite some time, the temperature should be a little bit higher. Also in children and in the bathroom, of course. So the right room temperature has a strong impact on our well-being. The optimal room temperature varies depending on where you are. For example, as mentioned before, office, bedroom, living room, or the gym. Only those who feel comfortable in their environment are correspondingly more productive and more vital. Here's the small overview that I mentioned before. And yes, you can have a look at the examples. So is this surprising information for you, or were you already aware of the different temperature ranges in accordance to the rooms? Also here, you can leave me quick little feedback in the question section. Next up, we'll go over the principle of individual room control, our today's topic. Here we see the principal representation of a room temperature controller. The room temperature controller, which can be seen in the box on the left, records the room temperature and sends a manipulated value to a valve or actuator. For example, the control valve is approached as a percentage. For example, 40%, warm water then will flow through the radiator heating circuit and transfers its heat to the room. The room temperature can then still be influenced by room influences. The room controller records the temperature again, and thus a control loop is created. Here you can see the loop. Also, in the room itself, there are various influences on the room temperature. For example, radiating heat from lighting. Electrical appliances in a server room, for example, will always be a little bit warmer. Or also from people in the room. One fun fact, one person emits a heating power of approximately 80 to 100 watts. The weather and the outside temperature also influence the room temperature, depending on the insulation and also the shading of the building. All these factors are compensated by the control system so that the room temperature is kept constant and under normal conditions. That's the goal of individual room control. In this example, we show the same schematic basically, but also as a representation of the individual room control. On the right-hand side, you can see our Kala. It's our Kala Touch, and a room controller that you can use for exactly what we're discussing today. So the Kala room controller shown compares the set point and the actual temperature and calculates the manipulated valve from this. The manipulated value is sent in percentage via the KNX bus to the heating actuator. This opens and closes the actuator or the valve depending on the controller setting. As a result, the heater gives off its heat to the room. Thus, the room temperature is always adjusted to the desired set temperature. The arrows drawn in the red show the hot water flow to the heater, and the arrows drawn in blue show the return flow from the heater. This is always a little bit cooler, obviously, because the heating energy got emitted to the room itself. That much about the schematic of individual room control. Please remember, if you have any questions up to this point, feel free to ask them. Next up, we're going to discuss the two-point controller. So on the right-hand side, you can see a thermostat that most of us know. This is a pretty standard thermostat. So the two-point controller is actually the simplest controller. This switches on when the temperature falls below the set point temperature and switches off again when the temperature exceeds the set point of the temperature. I think each of us know the classical bimetal thermostat. These thermostats are typical two-point controllers. In the above example, I have shown the function of the two-point control with hysteresis. So you can see the green line. The green line is our set point. Here in this example, it's set to 25 degrees. This could be in a bathroom, for example. The red dashed lines show the hysteresis range. We assume a hysteresis of plus minus 1 degree. This means that the controller switches the heating on when the temperature falls below 24 degrees and switches off again when the temperature exceeds 26 degrees. So the yellow line, you can see the valve is opened and the temperature rises up to the certain top level of the hysteresis. Then it's going to be turned down, temperature decreases, and that's how we try to get as near as possible to the set point. So when setting the hysteresis in the two-point controller, you need to take a few things into account. So there's a possibility of using a large hysteresis, a few on and off cycles of the heating valve. This is very gentle to the heating valve because, as we know, this can switch on many times, but it's also limited until you need to replace it. The regulation is also a little bit of inaccurate, so the control is inaccurate therefore. The temperature fluctuates around the desired set point at long intervals. The small hysteresis, on the other hand, has many on-off cycles. Therefore, it's not suitable for heating actuators with relays. The control hits the desired temperature more precisely, but you also need to note that the valve needs 3 to 5 minutes to open and close, and therefore it may not work properly if the hysteresis is too small. We've just dealt with the two-point control. In the next part, we learn about the PI heating control. So a PI controller is also called a continuous controller. It's very sensitive to the adaptation in variable to the different temperatures in the room. So a proportional integral controller, that's meant by PI. So a PI controller is so-called a continuous controller. So it continuously regulates the temperature. For example, the actuating variable can assume any value from 0 to 100. In simple terms, this means that a continuous controller can not only switch on and off, but also sensitively adjust the control variable to the temperature difference of the room. In the above example, I have shown the function of the PI controller graphically. So you have the light blue line. After switching on the controller, the temperature initially oscillates around the set point and then moves closer and closer to the desired set point. Our room controllers, which we will learn later about, have an integrated PI control. All the room controllers that we have at Elsner Elektronik have this integrated controller. Let's discuss the advantages and disadvantages of the PI controller. This will help you later on to assess which is the desired control method that you would like to use in your projects. Let's start with the advantages. So the controller regulates continuously. The desired set point is reached very precisely. The disadvantages are the setting of the control parameters is more complex. Also, this must be adapted to the used heating system. I also prepared different heating types. Each heating type has a recommended regulation. So we have the most classical hot water convector heating. For low flow temperature, the pulse width modulation, continuous controller, or two-point control can be used with a normal flow temperature of 45 to 70 degrees. This is pretty standard. Then we have the floor or wall heating. It's a very inert system, therefore pulse width modulation will be needed. What the pulse width modulation is, we will discuss in the next slide. So please be a little bit patient about that if you don't know what I'm talking about right now. Also, the continuous control with long cycle times can be used. Next up, we have the hot water or fan heater. For this control of the water circuit, the PI control is recommended. If a fan is switched together with the hot water circuit, the two-point control should be used. For electric heating, so for convection heating, the continuous PI control, and for fan heating, the two-point control is recommended. Let's discuss the pulse width modulation, as mentioned before. The KNX heating actuator, for example our KNX K4, receives the control value from the continuous controller and converts it into a corresponding pulse width modulation signal. In the following, we will have a look at how the pulse width modulation works. So for continuous control, it is necessary that the valve not only opens or closes completely, that we can also control the valve in various intermediate positions. This is realized via the so-called pulse width modulation control. The valve can move to different valve positions via the ratio of the pulse and the pause time. You can see this visualized in the graphic that we're seeing here. A small example. So if the ratio between pulse and pause corresponds to 50% each, the valve is opened 50%. This can be seen in the middle graphic, and so on. Next, we will have a look at the operating mode changeover for room temperature controllers. This is something you might know from the ETS, if you have worked with the ETS already. So HVAC stands for the heating mode. So HVAC stands for heating, ventilation, air conditioning, and cooling. This is very familiar to you if you have worked with any KNX thermostat or temperature room controllers before. So this HVAC mode can be switched. This HVAC switch can be used, for example, to lower the temperature on the control display when a room is not in use. It is conceivable to lower the heating depending on a period calendar, for example, to turn off the heating during school vacations. So for a commercial building, not only for a school, but also for an office building, of course. So you're having the automatic mode and you have the corresponding value of the KNX object. Also, we have the comfort temperature. This can be the comfort temperature if someone is actually in the room. This would be the 21 degrees. We have the standby mode. This is, for example, in the nighttime when no one is there. That would be the 18 degrees. Also, we have the echo mode for energy savings, which can be the 16 degrees. Next up, we have the building protection, so it's just protected against the freezing, so it doesn't get too cool and the building is not damaged because of the cold. Those HVAC modes can be set in many of our room controllers, but not in all of them. In the ones with the touchscreen, we have it implemented. In the very simple ones, we don't. But I can show you more about that later. All the temperatures controller are often controlled by a 3 times 1 bit controller. This is still sort of up to date since many of those are implemented in existing projects and it's good to know how they work. So as shown in the table, the operating modes can be switched by the means of a 3 times 1 bit value. In our products, you can select whether the changeover is to take place via the 3 times 1 bit object or via the HVAC modes. The values executed as X have no influence on the state of the operating mode. As we all know, nowadays, energy consumption plays a very big role. So we would like to not only to control the heating, but also to make it intelligent. For example, we have the ability to turn on the heating when people are present in the room and lower the temperature when they are absent. Another possibility is to lower the heating when the windows are open. We have shown this graphically here. On the left controller, we can set the operating mode to HVAC, priority 2. If the window contact in the room is closed, the detector remains in switch position 0 and no control of higher priority HVAC 1 is executed. In this setting, the manual setting HVAC 2 operating mode is executed by the controller. So if the window now is opened, the window contact switches the operating mode, for example, frost building protection, and activates HVAC operation priority number 1. As a result, the present operating mode on the heating controller is uncoupled and therefore no longer active. So if the window is now closed again, the operating mode of the manual setting on the controller is called up again. That much about the schematic. Let's have a look how this works with the products. Here in this example, I've shown again the color. The room controller compares the set point and the actual temperature and calculates the control value. The actuating variable is sent to the heating actuator in percentage. This opens and closes the actuator, or the valve, depending on the specification. The color has an additional binary input, via which a window contact can be integrated into the control. Via this window contact, the heating system can, for example, lower the temperature to frost protection mode when the window is open. The heating controller can also be controlled smartly via a presence detector. Here, for example, the heating could be switched to comfort when presence, meaning a person is in the room. Presence, and lowered to standby when absent. This is conceivable, for example, in the use of classrooms and offices. There is a huge energy saving potential by the use of individual room control with KNX, as I think we shown in this schematic very well. Next up, we will discuss the two-stage heating. This is sort of a special case. A two-stage heating system is usually a combination of a heater that reacts very quickly and with another one that reacts sort of slower. We have one example in the bathroom. So the underfloor heating maintains the standard room temperature. If a significantly higher temperature is requested via the thermostat or the set point is changed, the wall heating is additionally activated. So this means that the desired room temperature can be reached very quickly. That is when you use the two-stage heating. So we're already coming to the end of today's webinar. And as promised, in the end, I will show some of the Elsner electronic devices. Let me give you a quick overview over our room controllers and heating actuators that you will actually need to realize what we discussed today. First of all, we have the ETR series. So it has an integrated temperature measurement. All our room controllers, by the way, have an integrated NTC, so you can use this one as a control value inside the room the thermostat is installed. We also have this version of the room controller with a binary input, so you can add an additional NTC for the underfloor heating, for example. This is the ETR 101 BA2, stands for binary analog 2. Next up, we have the KNX ETR 208. It has an integrated temperature measurement, temperature control, but it can also switch and dim lights, also sunshade and open or close windows, for example. This can be also already used for a basic room with not too much functionality. Next up, our newest room controller of the ETR series. So this is the ETR fan coil. It also has an integrated temperature measurement, temperature control, but it can also control the fan level to low, mid, high, switch on and off the fans, and trigger the automatic mode. Next up, you've seen the Color series a couple times over the course of the webinar already. This is our Color Touch. It also has an integrated temperature measurement, temperature control. It can switch and dim lights. It can sunshade and open windows. Also, it has some binary inputs, so you can also connect some conventional switches, for example. This is the basic version of the Kala KNXT. We also have the full model also has AQS, meaning it can measure the air quality. So it has an integrated humidity sensor, temperature sensor, but also a CO2 sensor. So this is very useful if you want to integrate ventilation, for example. Next up in the Kala series, we have the Kala T101. Also with integrated temperature sensor and a temperature control that can be configured via the ETS. Next up, we have the Kala KNX Multitouch. This one has, once again, integrated temperature measurement, temperature control, but it also can switch and dim lights, also sunshade and the window control. One big difference is here, for the set point, we don't have a 7-segment display that shows the actual temperature. You can see there's the temperature symbol with a red LED when heating is activated, and when cooling is activated, this will be switching to a blue LED. Next up, we have the Nunio. It has an illuminated display, an integrated temperature measurement, binary inputs for NTCs, or for example, window contacts. It has a temperature controller, which the different HVAC switching opportunities, which you can see on the bottom left. And on the bottom right, you can also see that the fan speed can be adjusted. But this is just the second page of this product actually. It also works as a room controller that you configure as a 1, 2, 3, or 4 gang room controller. Also in the ETS you have a library of different icons that you can choose. So this is quite a cost-effective product that you can use for individual room control. So some information about the size. So this is a frameless series, no additional frame is needed. Next up, the backend devices. So we have different heating actuators. We have the 4-channel heating actuator. It has the pulse width modulation control and it has a maximum continuous load per channel of 8 watts. The inrush current is max 1.1 ampere per challenge. The advantages of such actuators are that if necessary, several valves can be clamped on one channel, taking into account the maximum current consumption. A standard heating valve is less expensive than a KNX control valve. Thus, it's saving costs. We have the exact same model, not with 4 channels, but also with 8 channels. We are coming to the end of today's presentation. We will stay in the webinar for a couple minutes longer and discuss your questions. I'll be back in a minute. All right, let's have a look at the questions, and thanks for the information that the microphone was still on. So the question is the following. Are there any controllers with the inputs dedicated for analog simple temperature probe sensor? Yes, there are in our range. Let's switch back to the models that have that. So we have the Kala series here. You can see the Kala KNXT on the left-hand side. This one has 4 binary inputs that can be used for exactly that. Also in the ETR series, as mentioned, we have 2 versions of the KNX ETR 101. So there's the ETR 101 without binary analog inputs, but also the ETR 101 BA2. If you would like to have more information about our products, feel free to shoot me a message. You can see my email and my contact details on the last slide down here. So feel free to contact me, to shoot me an email. I can also connect you to our technical sales team that can help you with all the technical questions regarding our products that are needed for KNX individual room control. I will wait a couple minutes longer in the webinar in case there are some more questions. To ones that I want to leave already. Thank you very much for attending. Please do me a favor and fill out the feedback form, as we would like to learn from the webinars and provide you the best possible quality of webinars that we can. And in order to get better, we need your honest feedback. Please be brutal and honest so we can learn from it. Thank you very much, and I'm wishing you a wonderful week ahead. Bye bye.